Today we're going to exponential functions. An exponential function is a function of the form y is equal to a times b to the power of x, where a is the initial value, also known as a y-intercept, and a cannot equal 0. B is any positive number other than 1. You also need to be familiar with the term asymptote. An asymptote is a line that the graph approaches more and more closely but may never cross. Specifically, our exponential functions will have a horizontal. So it'll serve as an invisible boundary line, again, that the graph approaches but never touches. An exponential function can be classified as either exponential growth or decay. If it's exponential growth, then b is greater than 1. When you look at a graph, you'll notice that the graph will rise from left to right. In other words, it'll increase from left to right. If it's exponential decay, then b is a fraction or decimal between 0 and 1. And when you look at the graph will fall from left to right. In other words, it'll decrease from left to right. Other important information about exponential functions is that if you have the equation simply y equals b to the power of x, then these 3 points will always be on that graph. So in the graphs that I have illustrated, those are both y equals b to the power of x scenarios. So that's why you see these 3 points on those graphs. So in other words, in that equation, a is equal to 1. So if a is some other number, then you're not going to necessarily see these 3 points, but at least these are some points that you can always start with and then manipulate them later. On this particular equation, the horizontal asymptote is y equals 0. Where does y equal 0? At the x-axis. So as you look at both graphs, you notice that they get very close to the x-axis, but never touch or cross because it serves as an invisible barrier that it's not allowed to touch. Then we need to talk about the domain of an exponential function. The domain is constantly moving from left to right, so therefore it's all real numbers. The range, however, may not go past that boundary, so that boundary serves as the starting point or the stopping point sometimes in other exponential functions, but in this case it's the starting point, sorry. So for these graphs particularly, the range is y greater than 0. When you look at the inequality, notice I didn't put the equal bar. That's because y is never allowed to be 0 because it's never allowed to touch the x-axis. But we know that it's allowed to get close, so that's why we just say greater than. So in this first example, we're going to identify the values of a and b and talk about what they mean. Then determine if it's going to be a growth or decay function. Sketch the function, and lastly state the domain and its range. So when I compared the given equation, y equals 1/4 times 2 to the power of x, I would probably write the generic form of the equation on top. That way I can quickly identify who is who. So in this case, a is 1/4 and b is 2. So since a is 1/4, that means the y-intercept is at 1/4. Since b is 2, that means this is going to be a growth function, meaning we're going to expect it to rise as we read from left to right. Before I graph, we can also establish what our horizontal asymptote is going to be. If you look above in the blueprint, it tells you your horizontal asymptote is going to be at k. Now, we hadn't talked about k before, but what you could see is from the equation right here that k would be some constant or number that's added or taken away from the a bx part. So in this case, since there's nothing being added or taken away, that means that k is 0. So with that being said, our horizontal asymptote, and I'm going to abbreviate with HA, our horizontal asymptote is going to be at y equals 0. And we talked about it on the previous slide. Where does y equal 0? Y equals 0 at the x-axis. So since it's already drawn, I would extend it with dashes so that we don't forget. And I would label HA. So that when after I plot my points, I'll know to remember never to touch that line. So now to graph, we're going to create a table. To create our table, we're going to start with the y equals bx formatting so that we can start with these 3 coordinates. All right, so that means x is -1, 0, and 1. When x is -1, according to above, it says y should be 1 over b. So in this case, that would be 1 over 2. When x is 0, y is supposed to be 1. And when x is 1, y is supposed to be b. So in this case, y is going to be 2. Now, to apply the a part of our equation, we're going to multiply a by our y values, and that'll give us a new y value. So our a is 1/4. We're going to multiply it with our current y, which is 1/2, and get 1/8 as our new y. Follow that same procedure all the way down. So 1/4 times 1 this time is still 1/4. And then 1/4 times 2, sorry, 1/4, not 1/4 times 2 is 1/2. So based on this information, our coordinates that we'll graph are x, which is -1, it didn't change, and our new y, which is 1/8. For the second one, it's going to be 0, 1/4. And the third is going to be 1 and 1/2. So we got to plot these 3 dots and we're pretty much done with our graph. I have 10 lines here on my graph. I don't want each line to represent 1. Remember, I have the power to label my units as whatever I desire. So I want each line to represent 1/8 for my y-axis. And then for my x-axis, I want each line to represent 1/2. So that means 1 would be right here, 2 right there, -1, -2, and so forth. I would label all the 1/8, but that'll just be too much. So knowing that's my scale, I can now plot accordingly. So our first coordinate is -1 and 1/8. So that would be this first line right here. Our second coordinate is 0 and 1/4. So that would be this second line here. And our last coordinate is 1 and 1/2. So that would be 4 lines up. Because if I have 4 1/8, I have 1/2. 3 dots plotted. I will connect them with a J-like curve. But again, remember, we're not allowed to touch the horizontal asymptote. And there we go. That's all it takes to graph an exponential function. Now let's talk about the domain and the range. The domain will be the same no matter what. So it's constantly moving, so all real numbers, and we can use the fancy R to say that. Our range is depending on whatever the horizontal asymptote is, and since the horizontal asymptote is y equals 0, we can say y is greater than 0. So that's our first one. So we got the same procedure or instructions for number 2. So let's begin. We can do this one a little faster. So A this time is 18. B is 2/3. And again, K is equal, which tells me again that my horizontal asymptote is at y equals 0. So let's label that on our graph first. I'm sorry, my pen has a mind of its own and it's not always going where I want it to go. Okay. So since A is 18, that means our y-intercept is going to be 18. Since B is 2/3, that means this is going to be a decaying function. And that's all we need for now. Let's build our table. So again, our x's are -1, 0, and 1. Our y's are going, for -1, it's going to be 1 over b. And that means in this case, it's going to be 1 over 2/3, which looks complicated. But 1 over 2/3 is the same thing as saying 1 divided by 2/3, which is the same thing as saying 1 times 3/2, for those who forgot how to divide fractions. So that means 1 over 2/3 is the same thing as 3 over 2. All right, so for 0, again, it's 1. And then for 1, it is b, which is 2/3. So these are the original coordinates. Now I need to find my new y by taking 18, which is a, times the old y. So 18 times 3/2 is going to give me 27. Then 18 times 1, 18. And then 18 times 2/3, which is going to be 12. And if you don't know how I got these numbers, please, by all means, use a calculator. So now the coordinates I will plot will be -1 and 27, 0, 18, and 12. So those numbers are pretty large. So again, when I draw my scale, I'm not going to use each line. I don't want each to represent 1. So for my y-axis, I want each line to represent 3. And then for my x-axis, I'm going to do the same thing I did before. Each line means 1/2. All right, so now I can plot. So -1 and 27 is going to be 9 lines up. So 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. 0 and 18 is going to be 6 lines up. 3, 4, 5, 6 right there. And then 1 and 12 will be 4 lines up. So that's right here. And then now we do our J curve that connects but doesn't cross the asymptote. And again, it's a decay, so it falls from left to right. Let's talk about the domain really quickly. That will be all real numbers. And then the range, again, y is greater than 0. We have one more example.